We are here with a new question. Leetcode question number 116, populating next right pointers in the each node. So we are given a perfect binary trees where all the leaves are on the same level and every parent has a two children. It means it is necessary that every node have only two children or not children. Not having a children means it is a leaf node. So the structure is such that it has a value, it has a pointer to its left child, it has a pointer to its right child, and a pointer to the next child. So we have to populate each next pointer to the point to its next right node. Means we have to populate the next pointer to the next element on the same level. Means one does not have any right sibling, so we will not point it to the right. So it does not have, so it will point to the null. 2 have right sibling of 3, so it next will point to the 3, and 3 doesn't have the right sibling, so it next will point to the null. In same manner 4 will point to the 5, but here is the mark. 5 should be pointing to the 6, 6 point to 7, and 7 point to null. So we have to return the root of the element. So main condition is key we cannot use the constant extra space. We know we can use BFS algorithm by using the queues, and we can get the label order traversal and we can mark the elements, but we does not have to use the constant extra space. And the solution should be not using any other collections like queue stack etc. So how we will process it? So this is our child. So we will first create a pointer of the leftmost. So first it will point to the root node. So the leftmost pointer always point to the leftest of each levels. Means it will point 1, it will point to 2, it will point 4, such that. And for the particular level, we will create a current. We will create a current. Initially, both are pointing to the root node. So we have to do such that either the nodes have two childs or not a child. So if the node have the left child, it means it also consists its right child. So we will check if the node having the left child, then we will mark its left next to the right. So we'll left will we will move left to the 2. So for this situation, we will check to have the left child. So we will mark 4 next to the 5. Then we have to check that if so now left will point to the 2, and we have to make sure that this is pointing to the null. We will see the code, then we will understand how it is working. So we will point to the 2, then 3, then 2 will point to the 5. So if it is not the right child of the parent, then we have to mark this. So since it is not the right child, it next have an element. So we will see that this current is here. So current dot right dot next, we will mark current dot next dot left. So now after marking this, we will go to the we will move current from this to that, and we will check whether its left side is not empty. So we will mark this with the 7, and we will mark this right next to the null. Then we will move our leftest most element to the 4, and after 4, 4 does not have a child, then it is not any purpose. to go to the further element because the element of the same labels have the same number of child. So we can see the code. We will check if the root is null, means we does not have any nodes, so we will return the root. Otherwise, we will create the leftmost element to the root. So we will iterate a loop left dot most dot left left most dot left is not equals to null. So we can see when we are there, if the node left does not have, it means it is the leaf element. So we have not processed the leaf element, then we can check the loop. We will terminate the loop and get outside. So for this particular loop, we will create a node named as current node, and initially we will name this as the leftmost element, and we will check while the current node is not equals to null. See, we are here, current node is here, left node is here. We will process this and this, then we will go to the next element. We will go there, we will process it, then we have to make sure that last element is marked with null. So this will mark null, this will mark null. So you can see there, last matlab, rightmost element should be marked as null. So we will check that current node is not equals to null. So if current node is not equals to null, then we will make their child attached. So we will do node dot left dot right, sorry, node dot left dot next equals to node dot right. Node dot left dot next equal to node dot right. So if current node dot next is not equals to null, means means if we have the right sibling for the particular node, then we definitely have this type of condition. To fulfill this type of condition, we will check if current node dot next is not equals to null. If it is not equals to null, then we will mark this. Means we will mark current dot right dot next equal to current dot next dot left. We can see here we will mark current dot right dot next equal to current dot next dot left. So after doing this, we will move our current to the right element, means current equal to current dot next. So current equal to current dot next. This loop will iterate, and after that, after the particular label finished, we will move the left to the leftest element. Leftmost element equal to leftmost element dot left, and our problem will be solved, and we will return the root element. So in this problem, we have to mark the next field value for the each node. So that's it. Thank you.